Arlinda is having a party and wants to fill her hot tub. If she only uses the red hose, it takes 3 hours more than if she only uses the green hose. If she uses both hoses together, the hot tub fills in 2 hours. How long does it take for each hose to fill the hot tub? This is a work problem. And what we need to figure out is the relationship between how each hose works, and then what part of the job would be completed in 1 hour. And then we can use those ideas to solve an equation to find what we're looking for. So let's consider, let's look at the red hose. Let's consider the red hose and the green hose, and working together, and build a little table for this. Alright, so the red hose, working alone, or the number of hours to complete the job. Now we are told that working together, if she uses both hoses together, the hot tub fills in 2 hours. So working together, it would complete the job in 2 hours. And we're told if she only uses the red hose, it would take 3 hours more than if she only uses the green hose. So if I say, well, let's call the green hose the amount of time it takes to complete using just the green hose, if I call that X, then the red hose is 3 hours more then that would be X plus 3. So let's figure out then the part of job completed in 1 hour. Or completed per hour, I should say. Well, if it takes X plus 3 hours to complete the job, then it takes 1 over X, or then it's 1 over X plus 3 parts per hour. And if it takes X hours to complete the job, 1 over X parts is done per hour. And if it takes 2 hours, then 1/2 is completed per hour. Now that we have these expressions, we can add up the part of job for the red hose plus the part of job for the green hose, and that gives us, that should be the same as the part of job together. So now we need to solve 1 over X plus 3 plus 1 over X is equal to 1/2. To solve this equation, it involves several terms with fractions. What I'll do is I'll multiply through by the LCD. And the LCD, the least common denominator, is just the product of the 3 denominators. So 2 times X plus 3 is the least common denominator. So multiplying through both sides of the equation and clearing fractions, I then have 2 times X times 1 plus 2 times X plus 3 times 1 is equal to X times X plus 3 times 1. Simplifying the expressions, I have 2x plus 2x plus 6 is equal to x squared plus 3x. Or more simply, combining like terms on the left, I have 4x plus 6 is x squared plus 3x. I see that this is a quadratic equation, so let me get one side equal to 0. I'll subtract 4x, I'll subtract 6. I'll subtract 4x, I'll subtract 6. Yielding 0 is equal to x squared minus x minus 6. And so now to solve this equation for x, this one will factor. I can solve this by factoring. And whether it factors or not, I could still apply the quadratic formula. I'll go ahead and factor though, since that's easier. So that would be x plus 2 by x minus 3. So then setting each factor to 0, x plus 2 is 0, or x minus 3 is 0. So then x is equal to negative 2, or x is equal to 3. Now let's go back and think about this for a moment. What was x? We said x was the number of hours to complete the job for the green hose. So since x is a number of hours, negative 2 doesn't make sense. We can't really have negative 2 hours. We can have 3 hours though. And so our conclusion then, since x equals 3, since that was, what was that? X was, again, x was associated with the green hose, and x plus 3 was with the red hose. Alright, so since x was the green hose, so then working by itself, it would take the green hose 3 hours to fill the hot tub. Or the red hose 6 hours to fill the hot tub. Where I got that 6, where did that 6 hours come from? Well, that was x plus 3. And x plus 3, since x was 3, 3 plus 3, and so that's where that 6 came from.